Welcome, everyone. My name is Brittany Todd, and I'm a member of the Fabric leadership team. Thank you all for joining us today for our 13th installment in our Stitching Together Innovation with Fabric users, led by Mohammad Sada. Before we begin, I would like to share a few housekeeping items. The webinar will include a live question and answer session following the presentation. Please note that the chat feature has been disabled. If at any point you have a question, please type it into the Q&A box at the bottom of your screen, and we'll answer it during the Q&A session. Last, this webinar is being recorded and will be shared with all registrants. Next slide, please. Next slide, please. We are joined today by our presenter, Mohammad Sada. Mohammad Sada is a researcher at SDSC, specializing in deep learning, high-performance computing, HPC, and advanced networking. His work within the Nautilus Kubernetes cluster at the National Research Platform focuses on distributed AI workflows, network programmability, and hardware acceleration with novel compute architectures, and scalable cyber infrastructure for data-intensive science. Next slide, please. I will now pass it to Mohammad to start the presentation.
Hello, everyone, and welcome, and thank you for joining us today. So we're going to be talking a little bit about joint experiments between Fabric and the National Research Platform. What we mean here by joint experiments is experiments that share the characteristic of high bandwidth connectivity that both platforms have and offer as a feature, both Fabric and the National Research Platform, or NRP for short. And to give you a little bit of introduction, if you're not familiar with Fabric or NRP, so Fabric is a research testbed. It's a collaborative platform between multiple institutions that have joined together into a research testbed infrastructure that is designed to provision resources in a way that, let me say, in a way where you can go in and test and design and prototype and have the capability of breaking things within a testbed environment and not having to worry. And Fabric offers various resources, and we've given this introduction multiple times. And between iterations, whenever I introduce Fabric, there's always something new, something exciting that is added. Between different FPGA types, different DPUs, smart NICs, network interface cards. So Fabric offers plenty of network resources that can be provisioned, including now also the P4 switches, physical switches. Between those various resources and the network infrastructure, Fabric offers the ability where researchers can provision these resources, create their own network topologies, create their own advanced networking experiments where they have the ability to actually run in a not non-deployment environment, a fault-tolerant environment where they can test. So as I was saying, so Fabric offers plenty of CPU cores, plenty of storage memory, both persistent and ephemeral, and memory and GPUs for any sorts of GPU workloads, as well as this is the more interesting part is the networking applications and the networking hardware resources that are available between dedicated smart NICs, dedicated DPUs, FPGAs that are capable of being fully P4 programmable, and physical switches, and the ability to provision virtual switches, and plenty of examples on how to do both. And the way the Fabric provisional model works, and this is how I like to explain it, is that Fabric exists, as you saw on the previous slide on the map. Fabric exists at various sites, various campuses, various research institutes, and those sites host Fabric hardware. So those are Fabric servers. And when you start your experiment, in Fabric terms, the experiment is called a slice. So when you're starting your slice between various sites, essentially, you're creating a topology between different VMs that you're starting, or in Fabric terminology, VMs are called nodes. So this is a very simple example in having two nodes, so two VMs that are connected together through layer 2 connectivity, for example, where each VM has its own network interface card, a dedicated network interface card or a shared network interface card, however I set it up. And my slice has the topology of my VMs. And as you can see here in the top part, Fabric comes with its own Python library that is called fablib. So the VM, you don't need to worry about how to provision the VM or how to set up that connectivity. There's an abstraction. There's a higher level concept where you can just use FabLib, start your own VMs, customize them and their characteristics between what sites they're on, what resources they're requesting, and include your network components. And you can just, with simple Python, request different types of connectivity between those components. Now, the example you're seeing here is a very simplified one where you have only two VMs on two different sites that are connected to each other. You can, of course, create more elaborate, more complex topologies. And you can do something even more interesting where you can actually connect your Fabric experiment to an external resource. So if you see here, this is also a simple example where I have one VM that is living on Fabric and coming from Fabric resources, and it's speaking out to the outside world, to an external resource through what we call facility ports. And if you want to learn more about facility ports, there's a dedicated webinar by Tom Lehman and Ben Formby discussing Fabric facility ports, what they connect to, how to provision them, and the details of how to use them. But that external resource could be something different. It could be some scientific instrument, could be a different federated environment. NRP is one example. Other examples are Chameleon, Cloud, Cloud Lab, and so on. But for our case, for our demo, for what we're talking about, that external resource is the National Research Platform. So for the sake of our demo, we're going to be having our Fabric experiment peek out through the facility port to an external resource, and that external resource being a testbed environment, a platform of its own, another cloud of its own that is called the National Research Platform. And very similarly to Fabric, it is also a collaboration and a partnership of many, many institutes. Right now, it's 84 institutions. Those institutions are institutions that have contributed hardware and contributed resources. So it's a community platform. The National Research Platform is completely open, both in terms of how everything is provisioned and deploying open source software and opening the model into how it's provisioned for distributed computing, and open in terms of anybody being able to access the resources or join in more resources. And it's primarily led by the San Diego Supercomputer Center at UCSD and the University of Nebraska at Lincoln and the Massachusetts Green High Performance Computing Center, MGHPCC. And it includes hardware and contributions from various sources between the NSF, the DOE, the DoD, and so on, and many RNE networks and exchange points and so on. And the way NRP operates is within the, let me call it, the canopy of one Kubernetes cluster. So all the hardware resources, all the software services, they're all provisioned into one Kubernetes, let me call it, hypercluster that is spanning across multiple continents. And the term for the Kubernetes cluster, the actual name of the cluster is Nautilus. So in many scenarios, when you hear Nautilus or NRP, they're usually referring to the same thing, which is the same pool of hardware, same federated environment where folks can join in and use the resources. And if you go, it's not appearing on the slide, but the link is dash.nrp-nautilus.io. On that link, if you visit it, you'll see a similar dashboard. You can see here the various sites that host hardware. Nodes is a Kubernetes term, so nodes means physical servers. So we have more than 500 servers. Even now, the number is more than 1,500 GPUs, various CPU cores, various software services, and environments that researchers can use, especially now since there's more and more use for AI, machine learning, deep learning. There's more of a fixation on requesting GPUs. So NRP is organically growing in the number of GPUs it has to provision and the number of AI services, for example, LLMs as a service that NRP has to provision. And it's all under the one Nautilus cluster, which has been in operation for more than 7 years now, because the National Research Platform is the development of a past project that was once the Pacific Research Platform, and it's ever growing, and it's crossing international boundaries now and borders now. And the cluster itself offers various resources, including various file systems, like the Ceph file system, S3 compatible endpoints, and so on, and various software environments. So by using NRP, you get access to some software services. For example, Jupyter Hub. There's an up and running Jupyter Hub service. There's an up and running GitLab service with the CI/CD pipelines and runners where you can build your own Docker images and use those in your Kubernetes pods, along with other various self-hosted software packages, including Jitsi, which is a video conferencing tool, among many others, as well as hardware resources. So to give you a brief overview on some of the hardware resources that are available on NRP, in terms of hardware, NRP has mostly x86 64 nodes between Intel and AMD processors, but it also has a small subset of ARM processors and ARM machines. And for GPUs, it's sitting at more than 1,500 GPUs now. Uh, Interesting is at the time of actually presenting this, they're all NVIDIA. But the interesting thing here is that they're not all data center cards, even though they're mostly sitting in data centers. We have relatively, give or take, 600 what are considered gaming cards, which are various GTX and RTX models like 5090, 4090, 3090, 1080. There's even a 760, if I'm not mistaken. And those gaming cards, provisioning them in an HPC fashion in a data center inside of a Kubernetes cluster, inside of data centers, inside of a Kubernetes cluster, Nautilus actually sees plenty of scientific applications where users are using those considered gaming cards, especially when it comes to applications with graphics and ray tracing and so on, and AI and ML and deep learning, especially in a classroom environment as well, where we can have classrooms where each student is getting their own dedicated GPU. And going up to more powerful GPUs like A100s, H200s, and so on that are more popular when it comes to provisioning very large transformer models, especially LLMs and stable diffusion models. We also have more and more hardware resources, very bleeding edge kind of hardware. For one example is the Qualcomm Cloud AI cards. We have the AI 100 Ultra. Those cards are multiple systems on a chip, so multiple SoCs. Each card comes as four SoCs. So each card is four modular systems that can be provisioned individually or combined in modular fashion. So we have one server that has eight cards. That equates to 32 individual devices capable of running PyTorch transformer models out of the box. So with an out-of-the-box config that relatively comes around to a 25 billion parameter LLM with out-of-the-box configurations. Of course, those numbers can vary depending on architecture and parameters and so on. But of course, that's all provisioned within Kubernetes. So within Kubernetes, users can specify their, let me call it asks, so what kind of hardware, what kind of resources, and we'll get to that in the next few slides. But to briefly give you an overview of available hardware, you can see here the distribution of different GPU models, and you can see here what the expectations of one hardware server are. So CPU cores, so we have between 16 and 384 cores per one machine, GPUs up to 16 GPUs in a machine, FPGAs, we have Alveo U55C FPGAs, those are programmable as P4 SmartNICs. We have up to four in one node, and also they're used for HLS applications as well, and RTL applications and processing acceleration applications. Memory, there's even more. There's 2 TB nodes and so on. And disk space, we have different scratch storage and provision persistent storage from storage pools. And network components, that's also another element. So network components, you have different ConnectX 6 and ConnectX 7 cards. And you have P4 Tofino switches, FPGAs, like we talked about. We have multiple types and flavors of FPGAs. I like to focus on the 32 U55Cs because those are enabled by ESNet and the ESNet SmartNIC framework. Those are very easily programmable as SmartNICs, and that's where an environment like the joint experiments we're doing comes in very handy, where you can have one topology going between different ecosystems and different platforms, between Fabric and NRP, for example, and different DPUs as well, like NVIDIA Bluefield 2s and Bluefield 3s that can be used also for joint experiments. Of course, all of this is under the canopy of one Kubernetes cluster that offers various persistent storage types, like we talked about. So between all the different file systems, all the different ways of provisioning storage, you can see here with this chart a live snapshot of how of the different storage pools, and you can see you have petabytes of the storage that are used by hundreds of research groups between data sets, between storing code, between different file system uses to enable research and education in classrooms as well. And of course, all of this, everything I've talked about NRP, this is all in NRP's documentation. And the documentation is sort of a small guide on how to use NRP, how to get access. So please make sure you have this link uh, up and ready. You have it saved somewhere, or you'll visit it from the slides. It's https://nrp.ai/docs. So it's just nrp.ai. That's NRP's website. The access model for NRP is NRP is completely open for research and education using CI logon. So when you go on NRP's website, you can just click login. It's a very similar fashion to how you get access to Fabric. So you can log in to NRP's website using CI logon, which also Fabric also uses CI logon. Using your institutional credentials, you can get in. And if you're a PI, a postdoc, or if you're a staff at a campus, an IT specialist, you can request the elevated privileges, what we call namespace adminship, where you can create different namespaces. And you can think of namespaces as scopes for different projects. From there, you can add users, you can elevate their privileges, you can specify what they get access to, what they don't get access to, and so on and so forth. And on NRP's website, also, this is very similar. If you've used Fabric, this is a very similar interface and how you specify in Fabric you have projects and NRP you have namespaces. So in namespaces you can see here you can add users. Once you add users, you can see, for example, my user is an admin, but if I add a new user, you'll see another button that says make admin or don't make admin or make not admin if you want to sort of demote. And you can create subgroups, so you can organize different projects and different hierarchy. And you can see here when creating a subgroup, you can see the check boxes. You have Kubernetes namespace. So when you create a group that is a namespace, you're creating a new Kubernetes project essentially, where users can provision resources. And if you check LLM group and Milvus database, you get access to more of NRP's features, which we're going to talk about in the next slides. So Jupyter Hub is one of the services that are available on NRP, and odds are you've used Jupyter Hub before in using Fabric. So in Fabric, you have a Jupyter Hub button. You can start your own Jupyter Hub instance where you can use FabLib. You can save your notebooks. Very similarly, you can use NRP's Jupyter Hub, which jupyterhub-west.nrp-nautilus.io. That's the link for NRP's Jupyter Hub. You can see on your visit and on your login you can see pickers in the web interface where you can select resources. So you can say, I want this much CPU, just this much memory, this kind of GPU. And there's an image picker when you can, for example, select a PyTorch image. And from there, you can launch your own instance. And this is an easy way to provision NRP resources where, say, you want easy access to GPUs, and you don't necessarily want to learn Kubernetes or understand a new environment. You can just use the UI, start your instance, and you have various options there, like PyTorch, TensorFlow, different software libraries that come preloaded. So you can see there's desktop images, and you can see here in this screenshot. If I select the desktop image, I have a launcher here. I can just click on it and it opens a remote desktop environment directly from my provisioning of NRP resources. Of course, all of that is documented more heavily in NRP's docs. Another thing is the NRP managed LLMs. So the LLMs themselves, they're provisioned in what is called OpenAI compatible endpoints. That means that's the way of provisioning the API access. So not to cause any confusion, they're not OpenAI models, they're open weight models pulled directly from Hugging Face. You can see here a subset that we're of what we're hosting, and you can check them out on NRP's docs for a live view on the available LLMs. But basically, you have API access where you can run scripts that use the LLMs, or you use front-end applications, chatbots. All of those are dependent on API access. Agentic coding platforms and tools, you can just hook up NRP's LLMs to that and have it assist you. For agentic coding is growing as a trend now. Just from my own personal experience, I do heavily use NRP's LLMs, and I've used them to help me in creating Fabric experiments before. And chatbot access also, if you visit the docs, and I'm gonna not gonna bother you with the details, but there's plenty of applications that we provision directly ready to use with the LLMs. So Libra Chat is one of them, and it has a similar interface to what you see here. where you can just visit the web page to reference in docs, and you can just to use the chatbot interface. Upload docs, ask it to write code, and so on and so forth. Now for this next part, we're just going to talk very briefly about how Fabric and NRP each work, how they provision hardware and resources, and how the basically the conjunction and sort of overlap is, and how that can be used for joint applications. So for Fabric, like we talked about, you have your VMs, you have all the software infrastructure that allows you to plumb paths between your VMs at different network components. For NRP, it's running native Kubernetes. So you're using Kubernetes to schedule your resources. And Kubernetes has an interface where you provide it with YAML or JSON, and that YAML and JSON specifies what you want. So it has your asks, and Kubernetes does the scheduling based on your asks. So let's say you specify, I want this much CPU, this much memory, this kind of GPU, I want four of this kind of GPU, for example. The Kubernetes scheduler handles the scheduling. So it looks at different servers and sees which servers, if there's at least one server that satisfies the requirements, it schedules on that server. So say I have a server dedicated for storage that is not a compute or a workload server, doesn't schedule on that. It looks in the other pool. Looks, for example, at this one, for example, satisfies my requirements. That's where my pod gets scheduled. You can think of a Kubernetes pod as a wrapper of one or more containers on a single server. So my Kubernetes pod is my simplest form of an experiment. And of course, one pod launches at least one container, and each pod runs on one server, not more. So pods get scheduled on one host server. But of course, one server can have multiple pods, and I can start many, many pods. And the pods I start within my namespace, which is the scope of my access, the scope of my experiment, the pods I start within my namespace, they can see each other. So you can see here in the screenshot, this is from an application called K9s or K9s. You can see those two are my pods, so hub and proxy, those are two Kubernetes pods. And you can see here the node, this is the host server. You can see here they both coincidentally started on the same host server, on the same node. But whether they did or they didn't, you can see they have an internal IP. So this is an in-cluster IP. This is not exposed to the outside world. But based on this IP, those two pods can see each other. And the reason here is because those two pods, among all the Kubernetes pods and containers, they exist within an overlay network, a VXLAN overlay network that is provisioned by something called Calico. So Calico is a container network interface plugin. Basically, what it does is that it's a system service that starts the overlay network where all the Kubernetes components can talk to each other. Which means within NRP, I do have an overlay network where my components can see each other and go through high bandwidth connectivity. Because NRP is on Internet 2's and ESNet's backbone, so it has high bandwidth connectivity between the different nodes and servers, which means my user experiments do have the high bandwidth connectivity on Nautilus and NRP and on Fabric. And now this is where the interesting part comes in, is where I want to join my experiments. So I have my NRP experiment, and the pods here have their own overlay, and I have my Fabric experiments, and the pods here have their own connectivity. And both do see the commodity internet. So I can have my Ubuntu experiment, for example, here on here, apt install packages. I can visit websites from both. I can access the commodity internet from both, but just because they both can see the commodity internet does not mean that's the path I should take for having joint experiments where I have one experiment going through both. When I want to combine experiments, this is where facility ports come in. So facility port, which is like we talked about, it's the pre-negotiated and preset connection between Fabric and the outside world. That's what I can use to combine between NRP and Fabric. And there's various in the artifact manager on Fabric's website, there's various examples of facility ports. And in facility ports, generally, you have a VLAN interface. So the facility port, let's say this is a VM, which is a node running in a slice on Fabric. and I connect it through an L2 network to a facility port. That facility port usually has a VLAN range. That VLAN range usually has something that it connects to on the other end. So the simple example is I have a scientific instrument in here and a pre-negotiated VLAN. And once I set that VLAN, it does the connection automatically. But here with NRP, we have another layer of complexity, which is I have Fabric, which is spread across the map, and I have NRP, which is spread across the map. And when I combine the experiments, but the experiments might not be overlapping. So say for the sake of argument, this is at UCSD and I'm running on the Fabric UCSD site, my NRP resource might not be at UCSD. It might be at campus Y or campus Z. And then that VLAN needs something to provision the plumbing. So my first problem is what can I use to actually start the path between Fabric and NRP? Because they might not be behind the same switch. They might not be behind the same data center. I need some sort of advanced orchestrator to start the path for me. So that's problem one, or problem three, as we said it here. What plumbs the VLAN between Fabric and NRP? Problem two is that I started the path, and now the path here is plumbed through a VLAN to the Kubernetes node, to the NRP host server. And now me as an end user, I have the path, I have this magical way of provisioning it. How do I configure that VLAN interface on the host in a multi-tenant environment? So how do I ask NRP, give me this network interface VLAN on the physical host? And lastly, it being on the physical host, how do I, as a user in my Kubernetes pod, which is essentially my Docker container, how do I get that VLAN? How do I see it in my experiment that has this magical high bandwidth connectivity? And that's where the ESNet Sense Orchestrator comes in. So the Sense Orchestrator, it's very beautiful in how it's designed. You can think of it as basically the secret sauce. It does all of those steps. So if I have my Fabric resources and VMs, my NRP Kubernetes pods, I can use Sense in the middle. And when I use Sense, it starts the VLAN path between the facility port and the NRP Kubernetes node. That's step one. Step two, it starts the interface on the host node. And lastly, I can use a Kubernetes tool called Multis. So similar to Calico, Multis is another container network interface plugin. What Multis does, and of course, I'm going to show you a demo notebook where you don't have to learn how to use those tools. You can just have a reproducible notebook. What Multis does is that it allows me to take the VLAN interface that is on the host node and just peek it into my own Kubernetes pod, my own experiment. And then what would happen is that I would have my VM that I can access with FabLib, and I have my Kubernetes pod, which I can just cube control into and just exec into. And I have an OS here, an OS here, and they both see network interfaces that are essentially running VLAN behind the scenes, but they both see network interfaces that enjoy high bandwidth connectivity without having to worry about the black box in the middle that does all of this, which is, of course, all enabled by Sense. And Sense, for more details, if you'd like to learn about Sense, so it's short for software-defined network for end-to-end network science at exascale. I'm going to give you the oversimplified explanation of what Sense is. Essentially, it's an orchestrator with an API that allows you to plumb L2 and L3 paths between sense-enabled endpoints. And sense-enabled endpoints is a big topology called the auto goal topology. What that topology includes is various NRP endpoints, various Fabric facility ports, other testbed environments like Chameleon Cloud and Cloud Lab, and various Internet 2 endpoints and various ESNet endpoints as well. And of course, here I'm copying slides from the ESNet Sense developers. And you can see here, this is what the architecture of Sense looks like. And the Sense model is API based. So there's an API you can talk to. And it does the plumbing of the paths. No need to worry about what happens behind the scenes. And just, I'm going to pause here at this slide for a few seconds if you want to copy the QR code, because the QR code is developed by the ESNet Sense team and it has a full tutorial on how to use Sense, as well as the tool links in here. Those two links are very useful if you want to learn more about federating from Fabric to other resources, both using Sense and using FabFed, which also relies on Sense and a lot of connectivity. And you can learn more on what you can do with Sense and advanced uses as well. But for our use on NRP, basically to abstract the level of using Sense, we've developed a Kubernetes native Sense operator. Basically, it allows me to use a REST API or a Kubernetes custom resource definition if you're comfortable with Kubernetes. And by using the sort of in-house deployed operator, you get the abstraction where you just do the same API calls and it starts the path for you. And it's easier management for us as well because we can one shot create the sense parts and the multis parts, which means less steps to go over in Kubernetes. And it's scoped for multi-tenancy, where you don't have to think of it as provisioning through three different resources, and the three resources being Fabric, NRP, and Sense. We can abstract one layer, and you can have your NRP part provision your Sense part, and then you can just reproduce the notebook and run the experiment from A to Z. And that's exactly what we're gonna do here on our demo. So I'm gonna switch over to my browser here, and this is my browser. If you're a new Fabric user, once you visit portal.fabric-testbed.net, you can see, assuming you have a project or are setups already set for starting, you can just click on Jupyter Hub. And this is the environment I'm using here for my experiment, which is right here. So this is my tutorial notebook. And if you want the tutorial notebook, it's on the artifact manager. So it's artifacts.fabric-testbed.net. And if you just search for NRP, here it is. You can see we just uploaded this morning. We uploaded up-to-date version of the notebook. You can download it and you can extract it. And you can see here, here's the notebook. Configure and validate. This is copied over from the Fabric Jupyter examples. This is if you're accessing for the first time, you can run that notebook and get up and started. But for our tutorial, this is our tutorial notebook. And the version that is uploaded still has the cell outputs. So you can see what the expected output of each cell is. But for the sake of time, I'm just going to restart and clear outputs for this one. And I'm just going to start running one by one. So if you go over the notebook, it has all the details you need. Some parts I'm just going to rush through just to have it up and running within our time limit. So I'm just going to run everything and then we're going to go through it together while it applies everything in the background. And just before we start the demo, in case it fails, I would really appreciate your patience. And the reason here is because we're federating through three different environments. So we're requesting Fabric resources, we're requesting NRP resources, and we're requesting the bandwidth as a resource through Sense. So there is, oh, sorry, expired refresh token. Let me try it again. Okay, let me restart. Let me restart fresh. There we go. So I'm using Beyond Bleeding Edge, but I think you can use the default, and I'm just gonna log in again. And here we go. All right. And as you go through the notebook and you're at your pace, please feel free to ping us with any questions you might have. But let me try to run it again. Hopefully we'll have better luck this time. And All right, here we go. So going over the steps real quick. The first part here is just introduction. Here, and for the sake of this notebook, we're using a temporary access through a pre-generated token, which can be used to access NRP. But for persistent access, you need to join NRP and have your own namespace. The steps are detailed both here with the links that for everything you may need. Step two, we're just installing dependencies. So we're installing the Kubernetes library within our Jupyter Hub to be able to use Kubernetes. And we are predefining our variables. So you can see here I'm defining a VLAN tag to use with the facility port. Of course, to know what VLAN tag to use here, you can run the notebook as is, and if it complains, it will give you the VLAN range, which you can see on Fabric's website as well. So you can see in our notebook, we're using the NRP-UCSD VLAN facility port. You can see the VLAN range it allows. So I'm using a VLAN within that range. The Kubernetes namespace I'm using, this is pre-filled for this tutorial. It works with this pre-generated token. And sorry, here the dates are old. It's more valid than that. And this is the namespace. So this can be changed to your own namespace once you get an NRP one. But for the sake of the demonstration, we're going to be using this namespace. And this is using FabLib. We're choosing Star, which is short for Starlight in Chicago, as our site. And we're calling our slice this generated name. And here we're starting our fabric slice. So you can see here, my fabric slice uses Ubuntu as the image with the NRP-UCSD facility port. And the facility port site is UCSD. And this is very important here. I'll show you what's happening. We're adding our node, which is our VM. And the site here is using the site variable, which is Starlight, not UCSD. And we're adding a basic NIC to it. And we're adding the facility port. And we've submitted it. Now, while it submits, if I go back to my Fabric experiments, let me log in, and I look at my slices. This is my slice. You can see in the example we're running, here on the left side, this is our VM. It's running Starlight in Chicago. And it's plumbing and connecting to the facility port in San Diego. Which means by using the facility port at San Diego, I connect to an NRP resource that could be at San Diego and have that high bandwidth connectivity. So a very cool feature in Fabric is that the facility port doesn't have to be in the same site as the node that it's being plumbed to basically. And here we're just installing, we're setting up an IP address. So we're going to set up an IP address for the interface that the facility port uses and an IP address for for the interface that faces the facility port. And we're going to set up an IP address for the interface that Multis gives us from Sense on the NRP side. Once we've done this, now part three is the sense setup. So this is the in-house sense operator we talked about. It's just the URL that you can curl at, and there's various API calls you can make. And this is what we're going to be doing here. So this is a reference for how to do it with curl. But since we're running everything in Python, all we did is convert those curl calls into requests within Python as functions. So the NRP endpoint is the name of the NRP physical server that we're going to be using. So it's linked in here. This link, if you open it, it lists all of NRP's nodes and host servers. So we're using one called node-2-7 at SDSC. So our experiment is going to go from Starlight in Chicago to SDSC at UCSD. And like we mentioned, those are all the same curl commands. You can see the token here that authenticates me as a user is the same token that is pre-generated, and it is ephemeral. It's only going to last for a few days, and after that, you will need to join NRP with your own namespace. But once you have your own namespace, you can pass that token in here, and you can use the operator, similar to how you use everything with NRP. And you can see I'm creating what we call a sense path between my facility port. So this is the Fabric given name for the facility port and the NRP given name of the node, and I'm specifying my bandwidth, and I'm specifying my VLAN tag. And I'm let me go down here. So I'm running create path, which creates my path. And if you can see here, this is show status. I'm going to run it again. So it's still in provisioning. I'm just going to give it a minute. So it's creating my path. You can see here the show status. This pulls a real-time status of the sense path. So it's still saying provisioning. I'm going to run it again. And you can see here in list paths, it says state active here, which is good. And it says active here. So my path is now ready. Now this is using what is called network attachment definitions. Of course, there's plenty of steps in here, but it's all explained in the notebook. So NADs or NADs are what Multus uses. So this is what they look like in YAML if you want the reference. But if I run create NADs, it creates my network attachment definition, which is what my Kubernetes pod uses. Showing NAD, this is what I have applied. So you can see here, this specifies the VLAN interface on the host. This is using this subnet range. And now my pod. So my pod is my experiment. It's my container wrapper. So get pod YAML suggests a pod YAML to use with the container that starts. But that doesn't mean you actually have to use that YAML. You can use a different, you can specify your own, you can create different experiments. And once I apply it, you can see here, I'm starting this pod, a pod on this host, which is the host we've plumbed to. And this is my pod's name. And now part 4 is the Kubernetes part. Also, this can be done very locally, very easily if you have kube control, which is the command line tool to use Kubernetes. If you don't, you can just run this notebook. And looks like I have something that is not very happy, but let me try to run it again. And once I have my pod up and running, I can just install packages. So this is my Kubernetes side. My VM is ready. I installed the packages. I set up the interface. Now on my pod, I'm doing the same. So apt update and apt install network tools. Of course, both experiments are ephemeral. So whenever I terminate my resources and start a new experiment, I have to rerun. And let's give it some time. And once the tools are installed, I can just test my connectivity between the two. Okay, this time it went through. It's installing packages. You can see this is my interface on my Kubernetes pod. So 192.168.1.2. This is on the Kubernetes side. And if I scroll all the way up to my Fabric slice, you can see here's the interface. Dot 1.3. So dot 1.2 and dot 1.3 dot 1.2 and 1.3, they live on two different platforms. But by running the notebook, I established the connectivity between the two, and now I can test it. And here we go. Let me run those and go up. So you can see I'm pinging. So this is running in the pod. It's pinging the VM's IP address. So you can see here sent for packets, and now I'm doing the opposite. I'm using the VM on Fabric to ping the pod, and we can ping. Now we installed traceroute and we're trying traceroute. So we ran traceroute on the iperf, not traceroute. We ran iperf on the pod, and we ran iperf. We installed iperf on the node, and we used it to send to the pod. Sorry, sending from the pod to VM. We started the server and we sent. You can see here, we've asked for 1 gigabit per second, but we didn't specify a quality of service class. We just asked for anything that is available. So we didn't specify a guaranteed quality of service in our experiment, but that is a feature that Sense does allow. So we're just going with whatever is available right now. And you can see here that I'm very easily doing 500 megabit per second, and I can go all the way up to 100 gigabit per second here because both the facility port allows it, Fabric allows it, and NRP, based on the nodes connectivity, does allow it for endpoints that do have 100 gigabit per second connectivity. And we have multiple advanced experiments where they've used very higher bandwidth, including 400 gigabit per second and 2 by 400 gigabit per second. Of course, all of that is enabled by Sense. You can see traceroute is just one hop away. You can see we're going from one IP to the other and starting a very simple HTTP server on the Fabric node. You can see that the Kubernetes pod on NRP, after all the installation here in this line, you can see hello from Fabric. It got this over an HTTP server running from Fabric uh, to NRP. Of course, in the end, you can run these cells here and get the SSH command, and I can just copy this over and paste it in the terminal. And now I'll be inside my Kubernetes, my Fabric node. And similarly, I can just copy this command generated by the cell. I'll show you my local terminal. Here's my local terminal. I can just paste this in, and you can see I am inside the pod now. So this is my Kubernetes pod. If I run fconfig, this is our interface that we set up, and this is its IP address. And lastly, once you run any experiments, please make sure to clean up the resources. The pod will automatically terminate, your sense path will automatically terminate, and your fabric slice will automatically terminate. But if you delete the slice, that will help alleviate the resources very fast, and other users can use them. That reaches the end of our demo. If you have any issues that you run into in running the demo, please feel free to reach out. And if you have any feedback, please feel free to reach out, and we'll be more than happy to uh, help out and offer hands-on support as well. And thank you all very much.
Thank you so much, Mohammed. Really appreciate it. We have a couple questions for you. The first question is, can anyone use the resources on NRP or does it require registration?
So for resources on NRP, anyone in academia, so if you're work in research or for any research use case or classroom use case, NRP is fully open, and the way to access NRP is through CI logon, where users can just use their institutional credentials. And if they have someone from their group who's a namespace admin, they can access. If they don't, they're the first from their group. We're one ping away where we can add them to a project, create a project or in a namespace for them and add them to it.
Great, thank you. Question two, can you tell me more about NRP and how are the resources distributed?
Yeah, so NRP is short for the National Research Platform. For resources, it's a community platform. So we have an initiative called Bring Your Own Resources. And basically, anyone or any institute, any research organization that has hardware, they can plug it in, assuming there is the network infrastructure for it and there are network requirements, which are basically high bandwidth connectivity. Anybody can join in hardware. So how the hardware is distributed, it's across the map in the United States. There are a few international sites, but it's generally at campuses. There is a higher weight for UCSD and UNL, which is the University of Nebraska-Lincoln, and MGH-PCC, purely because those three institutes are the initial grant that started the platform. So a big portion of the hardware is at those three resources still.
Great. I think you answered the beginning of this question, but I'll read the whole thing. Question three, how do I get access to the NRP and what is the typical resource allocation for a new research project?
All right, so for getting access, like we mentioned, please make sure you have the link either written down or memorized. It's just nrp.ai. So that's NRP's website. If you visit nrp.ai, you have a login button and you can just log in and you have the documentation and basically you'll have all the links you need to be able to get set up. And for allocations, each group doesn't get on NRP. The provisioning model is different from HPC systems normally and different HPC allocation systems. So users don't get an allotted allowance of, say, CPU or GPU or memory. And users can use what is available based on them trying to sort of monitor their usage. So anything that is put to good use, users can request. And any idleness and resources, of course, there's mechanisms in the cluster to reduce idleness. But as far as there are resources, users are more than welcome to use them without basically an allocation that is set in stone.
Great, thank you. The next question, since the Nautilus cluster has over 1,500 GPUs, what is the policy for a single researcher requesting a high volume of cards, for example, 16 GPUs in a single node, for machine learning training?
So this sort of ties into what I was talking about. So there's no sort of a set number of GPUs that users can't go beyond. So if there's no rule that says, oh, you've used too much GPUs, for example, as a researcher, but the reality of it is that it's a shared resource. So any idleness in resources means other users are waiting on them, on those resources to be free. So the way we enforce it on NRP is by monitoring utilization. That's for all kinds of resources, which does include bandwidth. So any sort of idleness in sort of reserved resources, that's where users need to sort of be careful in making sure no resources are wasted, purely because of demand and supply. So other research groups will be waiting on those resources.
Makes sense. All right, next question. How could a researcher benefit from using both NRP and Fabric? Are there unique resources available in one that are not available in the other?
Yeah. So as I tried to shed the light today is that both resources are very similar in offerings, but also have their unique offerings. So for me, the way I look at it is the benefit anyone would get from running today's experiment, where they have this high bandwidth connectivity, is where high bandwidth connectivity between the two platforms is something that is beneficial for their experiments. So one example is assuming there's an experiment that requires advanced networking components that Fabric has, like different DPUs, switches, networking applications, and requires a high number of GPUs, for example, like NRP has, then users can start that high bandwidth path and use both resources.
Great, thank you. And I think this is our last question. For a researcher who is comfortable with Fabric but new to Kubernetes, like on NRP, what was the learning curve like?
So Kubernetes does have a learning curve. It's not easy learning Kubernetes. It's not a trivial task. I'll give it the credit it needs to. There is some effort to be spent in learning Kubernetes if users choose to. We for NRP, there are models where users don't need to learn Kubernetes. Like you've seen with Jupyter Hub, you can just pick what you want as resources and start using the resources. So for a user looking for a simple persistent storage and a simple GPU access, you don't need to learn Kubernetes. But with learning Kubernetes, you get more power into specifying exactly what you want. So with Kubernetes, you can get down to the very granular details in specifying the hardware characteristics, the software environments that you want to provision for your experiments. So it's definitely worth the effort, in my opinion, to be honest.
Great, thank you so much. And I just want to give another thank you for a great presentation. Really appreciate it, Mohammed.
Thank you.
So, in addition to our presenter, we would also like to acknowledge the behind the scenes team listed here who worked diligently to bring this webinar to production. Next slide, please. And also, we want to thank the audience for your participation in today's webinar. In addition to a recording of this webinar, we will also email everyone who has registered a list of resources. This slide deck will be shared along with our Connect with Us form. We hope that you will reach out to the Fabric team for questions or support. Our next webinar is Mastering Fabric, Tips and Tricks webinar on March 17th at 3 p.m. Eastern. This webinar will be focused towards existing users, AI researchers, and testbed administrators. We would appreciate it if you could forward the information to the relevant users in your communities. And as a final reminder, please submit your Fabric matrix and make sure your project description in the portal is up to date, as we do use that information for our outreach, including our website. Thank you again, everyone, and have a wonderful day.